everyone, it's Alyssa and welcome to You Can Learn Math. Today's lesson is on imaginary numbers. The first question that seems to pop into everybody's mind is, how can you do math with something that's imaginary? Well, they're not imaginary in the sense that they don't exist. They were originally thought to be impossible, and so we're given the name imaginary, kind of making fun of it. But they're really useful. They have applications and things like sound processing and calculating things with electricity. They are useful. You do have to learn them, even though it seems kind of silly to have something that's imaginary. All imaginary numbers are based off of this, the square root of -1. That's the basis. Essentially, all your imaginary numbers are going to involve the square root of a negative number. So, square root of -1. Why do we say this is imaginary, that it's not real? Well, because a square root is a number multiplied by itself. So, both have to be the same. They have to be identical. There are no two identical numbers that multiply to -1, because if we have 1 times 1, we would get +1, and -1 times -1, we also would get +1. If I did 1 times -1 to get -1, well, that's not a square root because these two are not identical. +1, -1, they're not. So the square root of -1 is imaginary, and all square roots of negative numbers are imaginary as well. We write this as I, and yes, it always has that little fish hook at the bottom to make it easier when you're looking at your paper so you don't confuse it with a 1. And like, oh, is that a 1? Oh, is that a tiny dot? Yeah. So you'll always see it written with that little boop at the end. I have a video I did previously on simplifying square roots. Link is in the description below. That's very helpful with this, so I'm not going to go in a lot of detail. So I'm assuming you already know how to simplify square roots that are real or positive, because we're going to use those principles here in just a second. So if I had something like the square root of -16, and I am asked to simplify this, well, I say, okay, the square root of -16. Well, -16 is -1 times 16. So I can rewrite this as square root of -1 times square root of 16. The square root of 16 is 4, and the square root of -1 is I. So the square root of -16 is 4i. An interesting trait that I has is it's cyclical, or it creates a cycle when you raise it to different powers. And I'll show you what I mean. So if I started with just I, which is like the same as I to the power of 1, as we've said, that's just the square root of -1. Well, what if I had I squared? Well, that's the square root of -1 times the square root of -1. Any square root of something times the square root of the same thing, like say square root of 25 times square root of 25, that's going to equal 25. This is always, always true. So square root of -1 times square root of -1 is -1. So yes, you can square an imaginary number and get a real number. Then we have I cubed. That's square root of -1 times square root of -1 times square root of -1. Well, what is that? Square root of -1 times square root of -1, the first two here. That's -1 times square root of -1. Well, what's square root of -1? I. So I cubed is -I. Then we have I to the 4th. Square root of -1, square root of -1, square root of -1, square root of -1. All right, these two multiplied together, -1. These two multiplied together, -1. -1 times -1 is +1. positive one. So you have this pattern. And now we're going to start over again. Because if I do I to the 5th, if we use like our exponent rules, you could say, oh, that's the same as I to the 4th times I to the 1st. Well, what's I to the 4th? 1. What's I to the 1st? Just I. So I to the 5th is I. We're back here at the top again. So this is the same as I to the 5th. This is the same as I to the 6th. This is the same as I to the 7th. This is the same as I to the 8th. And it just keeps going around and around like that in multiples of 4. So if you are asked as a question, like say, what is I to the power of 27? Divide this power by 4 and then see what your remainder is. And your remainder is the power you're going to use. So in this case, 27 divided by 4 is 6 with a remainder of 3. So I look over here at I to the power of 3. So now I know I to the power of 27 is the same as I to the power of 3, which is negative I. I'm going to be following up this video. This is just intended as sort of overview of what I is and a basic sort of idea of how we can use it. I'm going to be having some videos talking about dealing with complex numbers when they're in fractions, simplifying complex numbers, things like that. So keep an eye out for those. I hope you enjoyed that today. If it was helpful, useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.